Hey guys, how's it going? So, I was not feeling well yesterday. I'm going to try those problems again that I was attempting. I have 2 hours. Let's see how many I can get done. So we were on the first problem right here, which was binary DQ. Let's see if I can get the sense out of it. So last time I was thinking something like say 1, 1, 0, 0, 1, 1. Let's say that S is supposed to be 2, which means we are supposed to remove how many? We are supposed to remove 3 ones from this array. And if that is the case, we can see that these 3's are the closest from here. However, if we approach this greedily, it's not going to be the most optimized way to solve this problem. So if I were to use a greedy approach where I would just look for the nearest one from the boundary right here or from here, if I were to use that approach, in that case my algorithm would go first here, 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 remove this one, then come here, this one. So that is how many? 1, 2, 3, 4, 5 operations. 5 operations here. Then we have 1, 2, 3, 4, 5. So 5 plus 5. These are 10 operations, which is not the optimal way to solve this problem. The optimal way would be to just come here 1, 2, 3, 4, 5, 6, and 7. So in 7 operations, we are able to remove 3 elements from here, 3 ones from here. So I need to keep track of these numbers right here. So that is one thing that I need to keep in mind. And we can also try to take this a bit step further. Let's say that what I can do is actually I can keep track of how many operations I am doing from the left side and how many operations I'm doing from the right side. And for after such number of operations, we can decide, okay, how many ones are we removing? Right? And if we know this, then we can make some sort of sense out of this problem. Let's see. Let's try. So what does a square root pressure curve look like? This is better. This is better. So I can start from here. I can say, okay, 1, 2, 3, 4, 5. So on 5 operations, we can do one. We can remove a single one, okay, and then I add 6 operations from the left side. We can lose 2 ones. On 7 operations, we can lose 3 ones. Dot 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 dot, and it will go right here. 8, 9, 10. Then we have 11. At 11, we can again lose 4 ones if you are starting from the left side. and similarly 12 is 5. So I'm trying to think about it in this manner. Let's see if this makes any sense. So one operation, two operation, three operation, four operation on the right side, and on the fourth operation on the right side we're losing our first one. Then we have another one to makes it two dot 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 dot, and so we can also do is we're right here 5, 6, 7, 8, 9, 1, 3, 11, 5. So this looks pretty interesting. Let's say if I were to decide now, I would say okay, first check from the left side the number of operations we can do. And it will tell me, okay, you can do we can, how many trees are we have to remove 3 ones, right? So we need to remove 3 ones. If that is the case, we can see, okay, if we remove a single one, we need 5 operations. If we remove 2 ones, we need 6 operations. If we remove 3 ones, we need 7 operations. And similarly, we can check from the right side that okay, we need to remove, how many we are going to remove, 1. If we remove a single a single one from this side, from right side, it's going to cause these many operations. Okay, so what I can think about it is, let's say we are going to remove x ones, right? We're going to remove x ones, and we can try this. We can say, all right, we're going to start from, we're going to check, we're going to kind of do a brute force right here. We're going to say, okay, how many operations does it cost me if I remove 1 from the left side and x minus 1 ones from the right side? Okay, so what I will do is I'll come here, I will say, all right, give me the number of operations. It tells me yes, we are at 5 operations, we can get this. And then if we come from the right side and we remove x minus 1 ones, we are going to get whatever operations right here. So that is going to be our answer. Then we come again, we say, all right, two numbers, 2 ones from the left side, x minus 2 from the right side. We're going to do a minimum of this and this, and greedily solve this. So this is my approach, and I think this is a pretty good approach. This looks really good to me. So I think we can now start. We'll now start thinking about the implementation. So this was a fun problem, and I believe it cost us how much time? It cost us only 10 minutes, so it's pretty nice. So we can make a pair, and the first time, so this is going to be an O of s log n, I believe. And I think we're fine. we're fine. We can do this in O of S log n probably. Yeah. And we also can do zero operation on the left side, right? We can also keep that in mind. We're going to start with zero actually. Zero operations on the left side, x operations on the right side. And so what is the case where it is not possible to remove to perform any operations? That would be the only case for that to be true would be is the only case where it is impossible to attain a sum of s is when the number of ones here are less than s, right? Ones are less than s, so we can just add ones, and in this case we are going to fail whatever they asked us. If one number of ones are equal to s, right, we don't need to do anything. So in that case, we need zero operations. And the number of ones is greater than s. In that case, we need to perform any sort of operation or something, right? So so x is going to be our. So we're going to have a count. So let's just start implementing this already. Okay. Forgot to install the extension. Give me a second. Companion. So let's spin this. So in NS, hmm. I'm thinking about the indexing right now. What would be the best indexing? I believe one-based indexing would be better. Would be, or I don't know, man. Hmm. Let's not do that. Let's just do zero-based indexing. We'll be fine. We're fine. So if accumulate is the right function, I believe a dot begin a or n is less than s, then see out this one. Also need to do something like all right. So we're going to say add the number of ones minus s, and this will give us what? I thought there was a function. Really? I don't know, maybe the parameters were not right. Which the case. That looks like the case here. So it's going to be first, last, beginning, tell. All right. Now what are we going to supposed to do now? Really check any possible answers, right? So in let's just not do that for now. Let's do something like this. Or in okay, okay. Let's just so oh no, okay. It's supposed to be all right. I just spilled some water. Anyways, and the implementation, the data structure that we can use is, I think map looks good. Map looks good. Map looks good. Map makes much more sense. All right. So we have a map of left operation, right? Before in I over 0, I left, and then I equals. Sorry, I is going to be All right. Map of int comma int, right operations. And we can start from for int I is equal to 0, I less than 10, I plus plus. So we're going to say, okay, in count of if a of I is equal to 1. So what are we going to do? We're going to say, alright, we found incremented, and then we're going to say left operation. We're going to say, okay, the left operations to get this count is supposed to be I plus 1. Okay, this is very weird. I'm going to start from for int j is equal to n minus 1, j is greater than equal to 0, right? J minus minus. I'm going to say if a of j is 1, we need to reinitialize your account as well. I'm going to say count is then incremented, and then I'm going to say right operations of what to get that count is equal to j is equal to n minus 1. So we are supposed to n minus j, I guess. So n minus j would work. N minus j is supposed to work. I believe so. Okay. Now we're going to say int answer is equal to so we can actually optimize this code. I like to optimize my stuff even though it doesn't make sense in competitive programming, so yeah, that's the so answer is supposed to be let's just say left operations. Time is our answer for now. We're going to say for int I is equal to 0, I is less than equal to x, I plus plus, and int j is equal to x minus I. Alright, we're going to say answer is equal to minimum of answer comma left operations to remove I stuff plus right operations to remove j stuff, right? And then this is supposed to be our answer, and we can just do this. Oh, we got it right on the first try. This is very good. We are off a very good start if we get this right. Alrighty. There we go. We got it accepted. Let's go. Let's try a 1300 problem now. 1300 romantic glasses. All right. Let's see where we are. So we solved this in 25 minutes. It's not bad. It could be better. Can't complain though. I was kind of lucky, but I believe that is. I'm starting to like get hang of some sort of intuition. Sometimes it feels like I have this idea that comes out of nowhere, and I have this gut feeling that this is supposed to be the right way to solve this, right? So it's kind of weird. I'm just thinking about it. Anyways, Lulia has M classes arranged in a line. Okay. The ice class has AI units of juice in it. Lulia drinks only from odd number classes, while her date drinks only from even number classes. To impress her date, Lulia wants to find a contiguous, I don't know how to pronounce this. Let's see. So it's contiguous, all right, contiguous, and American is also contiguous. So to find a contiguous subarray of these classes such that Lulia and her date will have the same amount of juice in total if only the classes in this subarray are considered. Okay. So Lulia wants to find a contiguous subarray of these classes such that both Lulia and her date will have the same amount of juice in total if only the classes in this subarray are considered. So only Lulia will consider stuff from the odd classes, and that subarray and the sum of that subarray is supposed to be equal to the second array, which is actually just even number classes. Find out if there exist two indices left right such that left is less than right, and all right. Okay. So this looks like a very straightforward problem. I believe so. Some questions have very small problem statements and makes it a lot easier to just read through them and start thinking about the problem itself. Some questions are very intuitive and you have to like do some casework till you come down to what you were actually supposed to solve. So this is pretty straightforward. All right. So 1, 3, 2, and Lugia has all classes, and let's just copy this entire test case. So I like to do it this way. Let's see. Let's start with first test case. Oh no, what is going on? Oh no, don't do that. Why are we switching to the wrong tool? What is going on? How do I fix this? Settings. So we are supposed to be an eraser, sir. We need to erase stuff. kind of weird. Let me restart this. So R0. No, don't do that, man. Don't do this. Shit. Why is it not working? Why is it not working? I don't want this. Oh God. Dude. How do I fix this now? Why are we switching to this right here? Not supposed to happen. This is not supposed to happen. We were fine. We were doing fine. And now it's doing this weird stuff. Why? I don't know where it is. Just screw it. God damn it. I don't like this, man. I don't like this. Anyways. Why? I don't want any more text. Okay. Now we are... What is going on? So we build this 1, 2, we have an array of 3. We want the sum of this, which is what 3. We want a subarray to form a sum that is 3, right? So this right here works, we have 3. Now let's come here, 1, 1, 1, 1. We got this and this, right? So that is 1 and 1 and 1, right? And the sum is supposed to be 3, so we are fine with that. Let's see, 1, 6, 9, 8, 5, 55, 3, 14, 2, 6. So, never mind. This comes with us, this comes with us, this comes with us, this is with us, this is with us. So the sum is supposed to be 6 and 6, 12 and 2, 14, 3, 17, 17 and 2, 19 and 2, 21. So the sum is 21. 1, 9, 55, 14 and 7. So we will start with this number right here. We will say, alright, are you smaller than 21? Yes, you are. Let's move ahead. Are you smaller than 21? Yes, you are. Let's move ahead. How much do we have right now? That's 9 over 10. And 10 and 55 is not working. So the complexity is supposed to be O of n, I believe. Yes, it is. So we need to be very smart with our numbers. we need to smartly determine when and when can we not form a subarray. So how do we do that? The first thing we can see is that this is obviously way bigger than 21. Doesn't make sense. So we're going to start right here. Let's see, 14 and 7. Does this make sense? This makes sense. The answer is yes, right? And the answer, what? Answer is no. So what is going on? So we were 6 and 8, 14 and 3, 17 and 2, 19 and 2, 21. It's supposed to work, man. Why is it not working? One and 9, and we have 5. Oh, we are not understanding the problem. We are not getting it right. It was not. I'm so stupid. This is not how it works. It doesn't make any sense, right? The way I was thinking doesn't make any sense. They gave us the numbers in this order for a reason, and what we were supposed to do is 1, 6, 9, 8, 65. Then we have 3, 14, 3, 14, 2, 7, and 2. 7. So Lilia has this, 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 and the guy has this, right? And we need to make some sort of separate such that we're gonna start our left from here. Then we can see, okay, our right comes here. We can have a prefix array that is very straightforward, so we don't need to worry about that. We need to worry about balancing our sums, right? And we can see, okay, right. So our right is a bit too large for us, right? What you can do is move our right forward. Oh shit. Now Lulia's sum becomes too large, right? Now Lulia's sum is too large than his dates, right? And then we say, all right, We can move this goalpost further down. And now this is 10 and this is what? 6 and 8. It is 14. So again, this is too large. So when do we move the left index? We need to move the left index as well. And we need to be smart about this. Let's think about it this way, right? Let's say that so we have Julia and then we have a Dave, right? So right now Julia's sum is 1, the guy's is 6. So how much is the margin? The margin is 5. Is there a place that we can move our left goalpost, that we can, whatever margin we move, that our either left or right, that we can fix this margin by exactly 5? We can do, so basically we need to increase this by 5, right? And this is not increasing, this number is not increasing by 5, right? We can move this here. And now we see, okay, we are now 1 and 9. We shouldn't try this stuff on on this test case because this test case is going to fail. Let's try it on something else. Let's try on this one. So 1 2 1 1 4 1 5 1 2. So so let's talk about Lulia and her date. So now left is here, right is here. So the sum that Lulia has is 1, his date has 2. We can see, okay, what we can do is Lulia is less than his date, so we need to move our right 1 step forward. Right comes here, then the Lulia's sum becomes 12, stays 2. Then what we do is again, this looks like a very naive approach right now. And now this gets increased by what? This gets increased by 4 plus 2 is 6. This remains 12. Move this again, 1 step forward. Now we have is staying in the steps. Give me a second. I have to take a break now.
बीस जुलाई 2025 को सोशल मीडिया पे ये वीडियो वायरल हुई जिसमें देखा जा सकता है कि एक लड़का और लड़की को गैरत के नाम पर कत्ल किया जा रहा है। रजिस्टर्ड एफआईआर के मुताबिक इन दोनों का ताल्लुक बलूचिस्तान के इलाके दगाड़ी के दो कबीलों से था।
हमारे जराये के मुताबिक इस खातून की शनाख्त बीबी बानो के नाम से हुई है, जबकि जो शख्स है उसका नाम एहसानुल्लाह बताया जा रहा है। दोनों की अलग अलग शादियां हुई है और दोनों के बच्चे हैं।
इन दोनों पे एक्स्ट्रा मैरिटल अफेयर का इल्जाम था।
इनके तकरीबन 9-10 माह पहले इनके नाजायज ताल्लुकात बने थे और ये भी इल्जाम लगाया जा रहा है कि 9-10 माह पहले जो है ये अपने घरों से भाग गए थे। तकरीबन 2 हफ्ते के बाद खातून जो है वो कहा जा रहा है कि अपने घर, अपने शोहर के घर और बच्चों के पास वो वापस आई है।
ईद उल अजहा से कुछ दिन पहले एहसानुल्लाह जब 4 माह बाद अपने गांव वापस आया तो दोनों के कबीलों ने इस मसले को मुकम्मल खत्म करने के लिए जिरके के फैसले के मुताबिक बानो और एहसानुल्लाह को गोली मारकर कत्ल कर दिया।
फैसले में ये इल्जाम उस पर लगाया गया था कि खातून और जो एहसानुल्लाह नामी शख्स है वो उनके नाजायज ताल्लुकात थे। उन पर सियाकारी के इल्जाम लगाने के बाद ये फैसला किया गया था कि अब उनको कत्ल कर दिया जाए।
वीडियो वायरल होने के बाद बलूचिस्तान के चीफ मिनिस्टर सरफराज बुख्ती ने सोशल मीडिया पे एक पैगाम जारी किया कि अथॉरिटीज इस पे सख्त एक्शन लेंगी।
मुकदमा जो दर्ज किया गया इसमें कत्ल, इक़दाम कत्ल और इंसदाद दहशतगर्दी के
The single greatest way to go from an intern slash junior dev into that mid-level senior level engineer is actually to rebuild projects that already exist. I know they say, hey, don't ever reinvent the wheel, and you hear this mantra all the time on Twitter. It's not good. It's okay. Try rebuilding Git. Linus did it in 5 days. See where you can get. Roll your own HTTP server. I guarantee you'll learn more about how HTTP works in a weekend than you will over years of just using it. Try implementing a small database just to see how they actually work, and then things will just make sense. One of the best quotes I ever heard was actually from Uncle Bob, where he said, don't let your employer lead you in your career. Lead your employer. Take the time to understand things. It may not immediately get you a better job, but it will open more doors the longer you stick with it. The single greatest way to go from an intern slash junior dev into that mid-level senior level engineer is actually to...
So, Sarah Getty is your great-grandmother. Yes, her.
This is the only car that can say it's the same weight and size as it was 30 years ago. A Honda Civic has gained 800 pounds over the last 30 years and is a foot longer, and a BMW M5 has gained a heartbreaking 1,600 pounds over the last 30 years. Even though this has a bigger 2-liter engine with 53 more horsepower, and even though you got modern safety tech like lane keeping assist, automatic braking, more structural support, and even things like airbags on the side, and even though we got bigger wheels, bigger tires, and even larger Brembo brakes, and even though we got a Bose sound system, a nice touchscreen with wireless CarPlay and Android Auto, and a reverse camera, if you get the soft top version of this Miata, not the hard top RF one like this 2025 Miata is only 70 pounds heavier than a 30-year-old 1995 Miata, and it's actually an inch shorter, which is insane. I gotta say, in a day and age where every car is getting bigger and heavier, Mazda deserves some respect.
Here's the highest paying remote job you can do from anywhere. No degree, no experience, and no social media following.
Alright, guys. Let's throw these cards. How do we so let's try this again. We start from left and right. So we check, okay, left is smaller than right. Yes, it is. Move right one step forward. Alright. Now what happened? Left is now greater than right. Okay. So is it possible that we move this forward and become equal to and keep the number equal? Is that possible? If it is, by how much are you supposed to move forward? This is a very weird problem now. I don't feel like doing this now. Oh, this is hard, man. This is hard to think about. So it's a very weird problem, man. How much is this possible? So what really is the correct answer to this problem? You can see 11 and 12 right here, and nope, can't do that. You can see that the only possible answer here, I believe, is this right here. No, sorry. I don't know. So we choose this, and let's see. Mm, mm, mm. 5, 4 is 9, and 2 is 11. Eleven and 2 is 13. It's not possible with this one. If we come here, we can see that this entirely is 13, right? So 11, 12, 13, and then we have 5 and 4, 9, and 2, 11, and 2, 13. So we have 13 and 13, right? So this is how it's supposed to be solved. Now the naive approach would be to do O of n squared, but that's not gonna work. How are we supposed to optimize this problem now? So let's see. This is really hard. So we can say we start from here, and then we come here. What happens now is that this suddenly increases by a lot, and now first this was smaller, right? Now this is larger than the text. So we can think about it this way, is in a way that we will see, all right, can we move this forward, and then can they be equal? Maybe, right? Is there a possibility? No, there is no possibility. So we move it forward now, and this goes here. Get 6. All right, we need a bigger. And now we see, all right, is it possible that, oh no, I don't, yeah, that won't work. That does not work. Okay, this is not a good idea. This is not the best way to do it. How do we solve this now? What is going on? Ah, I don't get it. How do we optimize this, man? How do we optimize? So here's the problem. Here is the problem that, let's say, okay. No. We can store the sums though. We can store the sums. Can this be a very simple VP problem? Oh no, it can't be, it can't be. Cannot be that. Let's say we compute the sums, right? So we say this 1, 1, 12, and then we have 12, we have 13, 13, 14, 14, and then we come from right. So it's what? 14. Sorry, it's going to be 0, right? It's going to be 1. Then it's going to stay 1, it's going to return 2, then it's going to stay 2, then it's going to turn 13, then it's going to stay 13, it's going to turn 14. And we can see the differences here. We can see it's 13 here, it's 12 here, it's what? It's 1 here, it's 10 here, it's 11 here, it's 12 here, it's 13 here. And we can also see start, if we talk about the blue numbers, right? So it's supposed to stay 0. Then we choose this number, it becomes 2, then it stays 2, then it turns 6, then it stays 6, then it turns 6 plus 5, it's 11, right? 11. Then we go forward, we say stay 11, it turns 13. Okay, what do we do now? We start from the right side. We say, okay, now, sorry, what am I even doing now? Let me write this again. So it was supposed to be 0, then turns 2, here's 2, 2. Sorry, this is supposed to be 6. 2, then 4, 6, stays 6, 6 and 5, 11, so 11, here's 2, stays 2, 2 and 5, 7, 7, 7 and 4, 11, 11 stays 11, 11, 2 is up to 11, 2, 13, and then 6, 13. So we can choose any number, right? We can choose any number from here. Subtract this, we get the sum of the subarray right here, and then we can compare that with the sum of that subarray. So it is just coming down to n squared again. I don't know how to do this now. Okay, let's try. I forgot to switch my timer. So we'll try for 30 more minutes, and let's see if we get somewhere. And let's see if we have any hints here. Okay, there are no hints. So so what do we do now? How do we do this in OFN? You can choose a number. Come on. I think we might have to use the editorial for this one. How am I supposed to optimize this? How am I supposed to optimize? So, what? Okay, we're right. So I will check this. Uh, okay. Looks a lot like Karen's algorithm to me now. Was romantic glasses.
Popcorn, Cornetto popcorn, caramel vanilla का flow, new popcorn.
Under the 1300 rated properties. So as you can
in every bucket there are some squares on the odd indices. Lulia drinks
Lulia is
only
such a
from
weird name,
these
man.
odd indexed elements.
Who names their kid Lulia?
Yeah.
Weird name.
You are numbered. Her date gets. This is what we have to tell. Is the problem clear? Like quite straightforward? Say yes or no, whether the problem is clear or not. Quite straightforward it is that there is an array. You want to find a sub-array. Like more formally, you can say that you have been given an array. You want to find if there is any sub-array in this array where the sum of odd indexed elements is equal to sum of even indexed elements. That's it. That's what the problem says. Like we have to find if there is any subarray or not, like this. Now there is one tricky thing which we can do. Like first of all, the thing you should be doing here is try to solve it with some approach which comes to your mind. Like you might think, you might realize that binary search doesn't make sense here. You can use a sliding window, but what will you do with a sliding window? So yeah, it also fails here. You can use 2 pointers, but what will you do with 2 pointers here? Yeah, again it fails here. And you might realize, like in my case, doing this part, I realized that, hey, if I just consider all these elements on the even indices as minus ai, as negative elements,
Mm.
if I just consider these elements as negative elements, in that case, I want to find a subarray whose sum.
Can you tell if this was made by AI? We made an AI content authenticity tool.
Is equal to 0. Can I say this? Can I say this? If I have an array A0, A1, A2, A3, A4, or maybe let me use one based indexing here, A1, A2, A3, A4, A5. I wanted to find some subarray where the sum of odd or the even index is equal to the sum of odd indexed elements. Can I say that it is quite equivalent? Like, since basically just convert this as A3 minus A2 minus A4 equal to 0. So if I just replace all the even indexed elements by negative of their values, like A2 being replaced by minus A2, A4 being replaced by minus A4, now the problem has got converted into, like, now let me call this as, if this is the array A, let's say this was the array A where I had A1, A2, A3, A4, and so on. I will say that I have an array A dash in which, so this thing makes sense. So array is the sum of the everything related to this problem. This is fairly easy, and a lot of here, like for this kind of problem, is just say elements still to 0, then the sum of the elements still here would be equal to the sum of elements still here, right? The sum of elements till this point would be equal to the sum of elements still there, because this part is a 0, right? Right? If this subarray has a sum equal to 0, let's say if there is any subarray whose sum is equal to 0, in that case, there will be some prefix whose sum would be, just imagine if the sum is p, then the sum of prefix till here would also be equal to p. And it is actually in the other way also. Any two prefixes is equal, then there would be some subarray, whose sum is equal to 0.
Okay, I get it. I get it. So that's pretty straightforward. Hmm. Very interesting. I have never. This is actually a very easy problem. Just couldn't make sense, man. So we'll say exists. We need to practice more array problems, stuff like this. Okay, we got a wrong answer. What did we miss? Hmm.
This now and is quite, and when you're just finding the prefix sum array is going to be a big of n stuff, big of n time complexity thing. After that, can do or a hash. So I got a wrong answer. I had thought that it would just get submitted and I had forgot about it, forgot about the problem. So here, first of all, I took the inputs. In case, like for every alternative elements, I just multiplied them with -1. Yeah, there was queue, there was very long queue while submitting problems. It was taking so long. Okay, after that, first of all, I took inputs. I multiplied every alternative element with -1. Then I declared a variable sum, which would be just storing the prefix sum. And I declared a set with long. I had made the mistake here at adding it to the prefix. Then just checking if there is any prefix like
Okay. No map should have worked. Mm.
Any you come to this line, it would just add the current sum to the set. I've just eliminated the silly mistakes. Yeah, you can declare int as long in the macros of what I had said here. I've just reduced.
I missed the edge case for some being 0 at any point, right? So I was only checking at the end. It was supposed to be checked every time, so this should work now. So that is it for today. I need more practice on these array type problems. We'll do like 10 problems probably would be enough. We'll practice more and then we'll move on. Alright, so let's call it a day. I will do div 2 in the evening. So right now I will work on some projects. I have been left hanging them for a long time. So see you guys.